you're having a better day than that. Come on. Fantastic. Okay, so it's a pleasure for me to be here. This is actually my first time ever in Brighton. I've never been to Brighton before. I actually grew up in a little town just outside of Liverpool called New Brighton. But this is my first time in Brighton Classic, in the original Full Sugar Brighton. And it's lovely from what I've seen so far. You've got a pavilion here. We don't have a pavilion in New Brighton, but we do have a Wetherspoons. So there we go. Anyway, so my name is Mike. I'm a web developer and Doctor Who fan, not in that order. And I am currently the lead engineer at a little startup called Zaptic. And at Zaptic, we make connected worker software. So that's about digitizing manufacturing processes. So front-end operators, people working in production lines, can have an easier time of their jobs because so many of those processes still actually pen and paper and clipboards. And so that's something that we're looking to try and solve. But in my spare time, I am on the board of directors of an organization called the Merseyside Skeptic Society. We produce educational and social events in the Liverpool area. We've been doing that since 2009. Also, since 2009, as Remy mentioned, I've been producing and presenting a podcast called Skeptics with a K, alongside my good friends Alice and Marsh, who are very, very dear friends to me. We also publish a magazine called The Skeptic. This has been running since 1987. We took over publication of that about 4 or 5 years ago. And we publish articles there several times a week. And I'm also on the organising committee of an event called QED, which runs in Manchester every year. And that's a big science and skepticism conference, convention, festival. And it runs over a weekend. We run it across like 4 floors of the hotel. It's brilliant. It's terrific fun. And the last one was just a few months ago. And dear Amanda, our caption today, also captioned the evening of Saturday night for QED, where she really got a hard time from the comedians. So I'm terribly sorry for that, Amanda. So those are the things that I'm involved in. Now, the more astute amongst you, I'm sure, will have noticed the repeated use of the word skeptic in many of my hobbies. And so you might be thinking to yourself, okay, Mike, you're a skeptic, but what does that actually mean? Does that mean you're like you're a climate skeptic? Like you think the IPCC is lying to us and global warming can't be thing because, look, it's a bit nippy out today? Well, no, that's not the kind of skeptic that I am. That's not something that I believe. Does that mean then that I'm a vaccine skeptic? And actually, I don't think you need a vaccine. You just put onions in your socks and bury a toad under an oak tree, and then that'll ward off the lurgy. Well, no, I'm not that sort of skeptic either. Skepticism, in the sense that we use it, refers to the principles of scientific skepticism. Scientific skepticism is the practice of questioning claims which lack good evidence. We do not think it is prudent to accept claims that do not have good evidence to support them. And this shouldn't really be a controversial position. It seems like a really bad idea to accept things as true when there's no good evidence to support them. But it also turns out that our brains are really, really buggy. And they will accept any old nonsense if you present them if you present that information in the correct way. So he bravely comes on stage at Brighton, puts up a big picture of Margaret Thatcher. This is an illusion that was created by a psychologist called Peter Thompson in 1980, and it's called the Thatcher illusion. And it appears on first blush to be a perfectly ordinary photograph of Margaret Thatcher, albeit upside down. But if I rotate this picture, it becomes clear about there that actually her eyes and mouth have been inverted. And if I flip the picture back, she'll appear to be superficially normal again. And I'm not fooling with this picture. I'm not doing it. There's not a morph going on here in the middle, switching out with the picture. All this is a plane rotation transform. And this is just an example of one of the bugs that we find in our brains, specifically in how our brains do facial recognition. So our brains are really buggy. And it turns out that it's great fun to fool with those bugs deliberately with things like magic tricks and optical illusions. They can be great fun things to play with. But more concerning for us are the bugs that we hit unintentionally, the bugs that we don't want to hit, because they hamper our ability to draw reliable conclusions and to make good decisions, because our brains will make us believe things without good evidence. So As software engineers, developers, coders, programmers, whatever you want to call us, we spend an awful lot of our time debugging. We look through the code, we go step by step, we try and figure out the flawed logic, the flawed assumption, the mistake that means our code isn't behaving in the way that we expect. But we don't always turn that rational and stepwise examination back on ourselves, on our own thinking and our own processes, we don't question our own assumptions and our own logic. So we often fail to recognize that our brains are very flawed and error prone. So let's take a look at some bugs in our brain that are less fun to fool with than optical illusions. So these cognitive biases are systematic errors in the way that we think, systematic errors in the way that our brains work. And this can impact on the judgments that we make, leading us to make inefficient or misleading or even harmful choices. And some of these effects are quite subtle, and it's just a little nudge, just a little poke in that direction, but that's enough to set you off on the wrong course. Some of them are much broader and much more obvious and much more of a club over the head. There are many, many of these effects. This is just a small subset that I found, and obviously we don't have time to talk about all of these today anyway, but we will talk about a handful of them. So confirmation bias. Confirmation bias is where we are more likely to accept evidence which affirms our existing beliefs and reject evidence which disconfirms our belief, which disagrees with things that we already believe. A great example of this is the Cottingley fairies. So this is a photograph that was taken in 1917 by two young girls called Elsie Wright and Frances Griffith. And it purports to show the girls playing at the bottom of their garden with genuine real-life fairies that they found there. They found fairies playing at the bottom of the garden. The girls played with them too, and they managed to take photographs of them. And this photograph came to the attention of Sir Arthur Conan Doyle, who was the creator of Sherlock Holmes, but was also a staunch believer in the paranormal and in spirituality. And such was Conan Doyle's desire to find evidence that supported his belief in the paranormal. He took the Cottingley fairies photographs and the others that were taken alongside this picture as true evidence of a real paranormal event that was taking place. And he promoted these photographs as such through London society in the 1920s. 60 years later, the two young girls in question, who were by now elderly women, admitted that the photographs had been hoaxed. And that, in fact, the so-called fairies were drawings that they had traced out of a children's book, mounted on card and stuck in the ground in front of them. But such was Conan Doyle's desire to find that evidence that affirmed his belief in the paranormal, that he wouldn't accept any explanation other than the fact that this was a genuine photograph. So we can be impacted by confirmation bias too, for example, in unit testing. In unit testing, we understand how our code is supposed to work, and so we can find ourselves writing tests to affirm our belief that the code works, rather than using our tests to try and break the code and find flaws in the code. So we might test the happy path. We might test the trivial error cases that we know we have handled. But we will miss bugs that we don't expect because our own bias about how we think our code works stops us even looking for those kinds of bugs. We use unit tests to affirm our assumptions about how our code works, rather than using tests to try and break our code. So this is one area where confirmation bias can impact us as in software engineering. Another example of this, and this is a very frustrating thing, is works on my machine. This phrase drives me up the wall. I quite often will ban it from teams that I'm working in. Works on my machine. This sidelines the evidence that our code is malfunctioning in favor of bolstering the alternate view that actually there's nothing wrong. Sounds like a you problem. I don't need to do anything because my code is absolutely fine. And this drives me bananas. What works on my machine does is prevent us from seeing and addressing flaws in our code, flaws that our customers might be experiencing, even to the detriment of those customers. So that's confirmation bias. That's one of the ways that it can affect us. This is an album cover, is what this is. This is an album that was published in the late 50s. It is the 4th greatest hits album put out by Elvis Presley, and it's called 50 Million Elvis Fans Can't Be Wrong. The conceit here being that if you don't like Elvis's music, you're telling 50 million people that they've got it. And what makes you think you're right and 50 million people have got it wrong? This is an example of what we refer to as the appeal to popularity, which can also in itself lead on to what is referred to as the bandwagon effect. Of course, it is not true 50 million Elvis fans can't be wrong. The quality of Elvis Presley's music is not determined by how many people have bought his records. You could argue that the opposite is the case. The number of people who buy his records is determined by the quality of his music. You could maybe make that argument. But even that argument doesn't really follow logically, given the number of records sold by X Factor winners you never hear of again, or by Mr. Blobby, right? Things could be popular without actually being of good quality or having any truth value. Now, this is going to sound like I'm having a pop, and it's not, I promise, but React. How many projects do we ship using React, not because React is a great fit for the problem space, but because React is just the popular tool. It's the tool we use. It's just the first tool we reach for. It's the default tool. Kubernetes, I think, is guilty of this as well. Kubernetes isn't always necessarily a great fit for the problem that we're working on, but so often we will ship a project on Kubernetes and leads to over-engineering the solution. It's microservices, and we've got all this infrastructure built around it, and all this nonsense. When actually, for the scale of application we're working on, a single application running on a single VM would probably be more than sufficient to handle us for the first 2 or 3 years of a project. This is what I refer to as fashion-based development. So like Postgres, Node, TypeScript, AWS, container-based microservices, Kubernetes, that's about the last 4 or 5 projects I've worked on. Despite them being different problem spaces, different customers, different end-user requirements, it's just the default stack that we reach for because it is popular. And popularity is a bad reason to choose a stack. We should be asking, does this solve a problem that we actually have? Does this technology solve a problem that I am currently experiencing with this project? We should be asking, does it fit within our existing stack? If we've got some existing code, does it fit within our existing framework? And maybe popularity is a factor that we should consider. It's much easier to hire React developers than it is to hire Svelte developers, not because Svelte is terrible. I dearly love Svelte. It's just there's more of them, so it's much easier to hire for React. It's easier to hire Node people and Dino people, as brilliant as Dino is, because of that popularity. But all too often, popularity is the only consideration that is on the table when choosing a tool. Anchoring. This is where the first piece of information we receive influences our later decisions. We see anchoring in marketing all of the time. So maybe you go to a cinema, you go to a beautiful old cinema like this one, and they'll be selling popcorn, and your popcorn comes in small, medium, and large. And the small is maybe £3, and the medium popcorn is like £6, the large popcorn is £6.50. Who's going to buy the medium popcorn, right? When for the only 50p more, you get like twice as much popcorn. The cost per kernel is way down there, right? Way down. Who's going to buy that medium popcorn? The fact is that medium popcorn isn't really there for you to buy. The medium popcorn is there to make the price of the large popcorn seem more reasonable. Because if it was just the small and the large, and you were looking at the difference between £3 and £6.50, you're going to, it's not really worth it for twice the price, is it? But for 50p more, it makes it seem so much more reasonable, the price of that large popcorn. Another example that we'll see of this in marketing was the original iPhone. At the time Steve Jobs walked out on stage to present the original iPhone, $500 was an absurd amount of money to pay for a phone. Steve Ballmer famously laughed at this, right? I'm sure everyone has seen that clip of Steve Ballmer laughing at the price of the iPhone. Steve walked out on stage and said, hey, we're doing this phone. And at the time, The top flight smartphones were things like the BlackBerry and the Palm Trio, and they were like less than $300 to buy. And so what Steve did before he announced the price of the iPhone is he started by anchoring the audience. So he said, this thing's got an iPod in it, and we think it's the best iPod we've ever made. And a great iPod's going to set you back $200. And also this thing's got a cell phone in it. We think it's the best cell phone ever made. And a great cell phone will set you back $300. So you're $500 out of pocket already before you've started. And then we've added in, we've done video on it. It's got this great touchscreen and there's Wi-Fi and we've got a real browser in it and it's the great email client. But we're still just going to charge you that same $500 that you would have paid if you bought an iPod and a smartphone. And that made the $500 price tag of the iPhone seem so much more reasonable than if he'd just come out on stage and say, we built this thing and it's twice what everyone else is charging. So marketing will often use anchoring to manipulate us. But anchoring is an effect that we need to try and avoid when we want to try and make unbiased and rational decisions. So we're most likely to encounter anchoring as software engineers in things like sprint planning. If I say, I think this ticket is 5 points, that makes it immediately harder for the next person to say, I think it's 30 points. It anchors the conversation around that initial 5-point estimate. And maybe they'll say 3, maybe they'll say 8, maybe they'll even say 13. But no one's saying this is 30, 40 points as soon as someone has said that this is 5. It anchors the conversation. Code reviews have the same problem. If I go in and do a code review and I say, I think this code is brilliant, it makes it so much harder for the next person to come in and say, I think this code sucks. Even if they would have had a different view, they had got to that patch first. And debugging is another area, debugging and troubleshooting. Often we can anchor ourselves around that initial idea of, I think it's this, and we spend all of our time chasing down that initial idea, trying to prove or disprove it, to the exclusion of other suggestions that might actually be a better fit for the evidence that we have. I'm sure some of you will have seen this diagram before. This is based on data gathered by the US Air Force in 1943. And each of these little red dots on this diagram of a plane represent an area where the plane had taken damage after it returned from a mission. And so we can see from the diagram, the plane has taken damage on the wings, it's taken some damage on the tail, it's taken some damage on the fuselage. And so the naive reading of this diagram might be, okay, maybe we need to reinforce those. That's where the planes are taking damage, so we need to reinforce those areas. Maybe put armor plating on it or something. I don't know, I'm not an aerospace engineer. But the naive reading of the diagram is that. In fact, this diagram tells us the exact opposite of that. The reason the damage is only in these areas is because these are the areas that the plane can take damage and still return to base. Because the planes that were shot in the engine, the planes that were shot in the cockpit, didn't make it back to base in order to make it into this data set. This is an example of survivorship bias, where we focus on successful examples and we ignore failures. And this gives us a skewed understanding of what works and what doesn't work, what's the right choice and what's the wrong choice, because our data is being drawn from a biased sample. So, again, as software engineers, as developers, we might look at successful companies, look at companies like Facebook, like Amazon, and say, let's do what they did. Let's use the technology they used. Let's pursue that line because we know that's a path to success. Look at this huge company using this technology stack. We know this is a path to success, which will lead to us over-engineering our solutions, publishing microservices, doing event-driven architectures, big distributed databases, thinking that this is going to bulletproof our application for the future. Or Hadoop. Does anyone remember Hadoop? So Hadoop was an open source implementation of Google's MapReduce engine. Google wrote this white paper saying this is how our big data processing engine works. We call it MapReduce. And they wrote a white paper describing how it works. And someone took that white paper and re-implemented it in open source. And I think it's an Apache project now. And so many projects jumped on Hadoop when it came out to try and solve their big data problems, without recognizing that they never had big data problems. 3 million rows in your database is not big data. That's not a scale that you're operating at. It's not a scale that 99% of us will ever operate at. So survivorship bias makes us look at big companies, look at their technology, look at their solutions, and think that emulating them will bring us success. And ignoring all of the other companies who used all those same technologies, used all of those same patterns, and failed and crashed and burned. Another example that you might see in software engineering is at events like this, where you'll have a Googler who'll come up on stage and give a spectacular talk, and a hand will go up in the Q&A and say, "Hey, I want to get into Google. How did you get into Google? Tell me how you got into Google." And I think this is tantamount to saying, what numbers did you play to win the lottery? Because then I'll play those numbers, and then I'll win the lottery as well. Because the Googler will then stand up there on stage diligently and say, well, I was working at this little startup and I wrote this blog post and it kind of took off, and then I did this great conference talk and, it kind of hit it off, and then Google reached out. And ignoring all those other engineers who also worked at little startups, who also did great conference talks, who also had blogs that took off and didn't end up working at Google or Meta or Apple or whatever. So that's survivorship bias. So there are many, many dozens of these effects that we can encounter on a day-to-day basis, and we are unable to escape our biases. A very common pitfall is you think, well, I know about it now, so it's not going to happen. That's not true. Our biases are hardwired into us. It's very, very difficult to escape them. But we can try to learn how to manage them. And that's what critical thinking helps us do. Critical thinking is the debugger for your brain. Critical thinking helps us evaluate evidence and arguments and form conclusions that are, as far as possible, rational and free from bias. Critical thinking will help us structure our thinking, ensuring that what we believe is grounded in truth and evidence, interrogating our assumptions, and critically evaluating the evidence that is presented to us. I kind of think of critical thinking as treating every day like it's April Fool's Day. So if you turn the news on one day and you say, oh, it's terrible, the spaghetti harvest has failed. What are we going to do? There's going to be a pasta shortage this winter. And then you look at the date and it's April the 1st. You go, really? Is that really how that works? Does spaghetti really grow on trees? I don't think spaghetti really grows on trees. And we are very, very good at that on April the 1st. And we are terrible at that for the whole of the rest of the year. And what I am suggesting is that we should take that same diligence that we have on April Fool's Day and we should apply it to the rest of the year. Because on April Fool's Day, we're hyper-vigilant because we know that people are deliberately trying to mislead us. And the rest of the year, we're trying to mislead ourselves. Our biases are trying to mislead ourselves. And that same skepticism, that same curious questioning attitude can help fight against those biased views. So question your assumptions. A true assumption will hold up under critical examination. The truth has nothing to fear from critical examination. The only assumptions that are going to crumble under critical examinations are unsafe assumptions that were on rocky ground to begin with. So questioning your assumptions. Checking your sources. Who says this? On what basis do they say this? What is their expertise in this area? Does this person know what they're talking about? Not just copy and pasting some code from Stack Overflow. We should prioritize evidence over opinions, focusing on data, focus on deliverable, observable, measurable outcomes, because they are less likely to be influenced by our personal biases. Not zero likely, but less likely to be influenced by our personal biases. We should practice open-mindedness. Recognize that you might be wrong. You might have got this wrong. When you're given new evidence that contradicts your position, change your mind. This is something that drives me up the wall about politics. When a politician changes their mind, they're harangued by the media for flip-flopping. Where changing your mind in the face of new evidence is actually a laudable thing to do. And think systematically. This is something that we can actually do because we're software developers and we do think systematically when we are coding. We just don't always apply that to our personal thought processes. So human beings are not natural critical thinkers. We're actually spectacularly bad at this. But it is a skill that we can learn, and like other skills that we can learn, we learn best by practicing. So let's practice a couple of these now. Who's seen this one before? You should go backwards over a loop. You should decrement the counter. Don't increment the counter, decrement the counter because it's faster. You should do that because it's faster. Has anyone had this one? Show of hands. Has anyone heard this one before? Going backwards over a loop is faster. It's faster. The reason it's faster is because comparing to 0 is optimized in hardware. It's optimized in hardware, so it's faster. And in fact, you should use a pre-decrement operator, not a post-decrement operator, because a pre-decrement operator is 1 assembly instruction, and a post-decrement operator is 2 assembly instructions. And so it's like twice as fast, right? You should do it like this. But let's think about this critically. Will this actually result in fewer assembly instructions? This is the claim being made, is that writing a loop like this will result in fewer assembly instructions. But there are so many interpreters and JITs and optimizers and caches sitting between the code we write and what executes on the CPU. Do we really think it's actually going to make a huge amount of difference? Maybe one day back in the annals of history when we were all writing on 6502 processors on a Commodore 64, maybe that would have made a difference back then. But today, in JavaScript, do we really think that this is going to be the difference between slow and fast code? If the difference between 1 assembly instruction and 2 assembly instructions is the difference between your code being fast and not, you are already running an application that's faster than 99% of the rest of the internet, if that's where the bottleneck is in your performance. If you think decrementing a counter is going to make a meaningful difference to the performance of your application, you should question yourself. How do I test this? How do I check if this is the case? How do I check if this is not the case? Measuring where your performance is failing and tackling that problem, not following the set of holy performance axioms. Are you sure that this is where your code needs to change? This is a bug that I encountered a few years ago. I got a phone call from the QA team, and they said, "Mike, payments are failing. Payments aren't working. We just shipped a new payment flow. I'd worked really hard on it." So I said, "Okay, I'll check. I'll fire it up." So I loaded up my laptop. Worked absolutely fine for me, which is really weird. So every time I tried it, it succeeded, and every time they tried it, it failed. So we thought, okay, let's try and think this through. So we started eliminating variables. Let's try. We were both using Chrome. Let's try Firefox. Succeeded for both of us in Firefox. All right, let's try it in Safari. Payment succeeded for both of us in Safari. Only failed in Chrome. Failed every time for them. It failed. Every time for me, it succeeded in Chrome. And only Chrome for Mac. We tried it on Windows. Worked fine in Windows. Only Chrome for Mac. So we thought, okay, what else can it be? We would both have the same model MacBook. Couldn't be that. We were both running the same version of Mac OS X, so it couldn't be that. We eventually hit on a point of difference between the setup QA was running and the setup that I was running. I had an external monitor attached, and QA didn't. They were just running on the Mac laptop. So it turns out that most displays these days use 24-bit color. That's 8 bits each for the red, green, and blue color channels. But the Mac, with its wide color gamut, uses 30 bits to describe color, 10 bits each for red, green, and blue, for a total of 30 bits. And during payment, in order to support 3D Secure version 2, our payment processor was fingerprinting the browser. So they would take the height of the window, the width of the window, user agent string, stuff like that, including the color depth. So this is the kicker. This is from the CSS object model view specification. It says that the color depth should be an unsigned integer, and it should return number of bits allocated to colors for a pixel in the output device, excluding the alpha channel. That's what's in the CSS object model view specification. The 3D Secure specification, however, says that color depth is a 2-bit enum field that has the acceptable values of 1, 4, 8, 15, 16, 24, 32, or 48. So according to the 3D Secure specification, 30 bits is not a valid bit depth. And that's why our payment was failing. They were fingerprinting the browser and saying, that's not a real browser because a real browser can't have 30 bits of bit depth. So what's this got to do with critical thinking? So it turns out that in 2013, somebody made an update to the W3 Schools page for the screen.color_depth API. And they enumerated the possible values as 1, 4, 8, 15, 16, 24, 32, or 48. Now, W3 Schools, despite their name, is not affiliated with the W3C. They have no authority whatsoever on web standards. They are a very well-meaning, very small organization based out of Norway that have spectacular SEO somehow. But as a result of this, somebody at EMVCo, who writes the 3D Secure v2 specification, took this information as gospel and baked it into the 3D Secure version 2 standard. And nobody noticed until Apple started shipping wide color gamut displays. And the CSS working group, I should lay a tiny bit of blame at there, also said, hey, let's start reporting the color depth as the true value, because up until that point, they decided it was fixed at 24, because that's where everyone's values were anyway. Incidentally, that's why it worked fine on Firefox and Safari, because they all reported 24 regardless of the true bit depth of the screen. It was only Chrome that was reporting the true bit depth. But this is why you should check your sources. Evaluate your sources and the quality of information that you are received, because if somebody at EMVCo had done this, this would not be a mistake in the 3D Secure version 2 specification. As it is, they have to send out a note to implementers saying, by the way, this is in the spec, but also if you get another value, accept that as well. And some implementers have done that, and some of them haven't. And I wrote a blog post about this, and every so often there'll be a new comment appear on the blog post saying, I had this bug today too. So W3 Schools are not authoritative on web standards, but they were taken as such, causing this bug. This is why we should check and verify information from our sources, question your assumptions, critically evaluate the evidence that you receive. So bringing critical thinking into software engineering can improve our skills, it can improve our teams, it can help us build more better and resilient products. Our goal is not always to ship code. Our goal is to solve problems in a robust and adaptable manner. And that might mean shipping code, but there are many, many other processes other than just sitting there and power typing. One way that we could try and solve those problems is by fostering a culture of questioning and curiosity within our teams. Now, there's much, much more to skepticism and critical thinking than I've been able to present here, but I hope your curiosity is piqued enough for you to want to look into the topic a little bit more. If that is the case, then my challenge to you is, when you go back to your teams next week, question one assumption. Just one, pick one, and check it. Go back, evaluate, is that assumption true? Is this the correct predicate that we have built our code on? Test that assumption. Think about the assumptions and the biases that you have. And also encourage other members of your team to do the same thing. And then see what happens. Measure it. Observable outcomes. Check the evidence. See if this actually makes a difference to you and the projects that you're working on. If you're interested in hearing more of this sort of stuff, I do a podcast called Skeptics with a K. We don't talk about software often. We don't talk about software very often at all, to be honest. When we do, it's always me. But we talk about all sorts. We talk about a huge range of topics on this show, from bogus PR to pseudoscientific medicine to crazy conspiracies and flat earthers and all sorts of stuff, all from a critical perspective of, is this true? How do we know? How can we tell? So you can find Skeptics with a K on anywhere that you get your podcasts. We also publish several times a week at The Skeptic. There's an article from me went up a couple of days ago about the placebo effect, and if you want to come and find me, I'll tell you about why that's a load of nonsense as well. And you can also find me on Blue Sky at MyCall314. That's it from me. Thank you very, very much for listening.